I bet you've experienced retrieval augmented generation without even realizing it. What is it? Glad you asked. It's time for another Control Alt AI. Have you ever used an LLM like Copilot or ChatGPT and gotten a crazy wrong answer? Well, those are called hallucinations, and they're a common problem for large language models. But even worse than getting a blatantly wrong answer is the fact that they are so confident in what they're telling you. They present that wrong answer as factual, even though they have no sources that they can cite to back up their wrong answer. Let's look at a recent conversation I had with an LLM where I asked it if a number was prime or not. Look how authoritative it is. It's breaking down all the ways that it's answering and solving this question. But what happens when we ask it to check its work? Okay, well, at least now it's admitting it's wrong, but math is easy to check and verify. What if this was a health-related question? Or what if I was researching a company to see if it's a good investment? Wrong answers from out-of-date information could cause real harm. And that brings us to another problem with large language models: outdated data. Large language models get their name based on the large amounts of data they're trained on. And when I say large, I'm talking like whole internet size. A lot of information. But think about how quickly information changes. Heck, if that model was trained on data pre-2006, it still thinks Pluto's a planet. And if it was trained on data from pre-2025, it's not sure who the current president is. But training these models takes a lot of resources. For instance, GPT-4 is a well-known large language model that was released by OpenAI. And in 2023, their CEO stated that the process of training it cost well over $100 million. So constantly retraining these models is prohibitively expensive. Okay, Michael, we get it. LLMs have their issues. They answer wrong sometimes, but make it seem like they're right, and their data can get out of date. But what does any of this have to do with retrieval augmented generation? Well, stay with me. We're still setting the table a little bit, but we're getting there. Let's look at the flow of an LLM to see how it works. A user will ask a question, and if you remember, we call that a prompt. The LLM will think about that, and it will generate a response. That's where we get the generation in Retrieval Augmented Generation, or RAG. So clearly, the Retrieval Augmented part of this is what makes RAG different than just a traditional LLM. All right, we've got the ingredients ready, the stove is hot, it's time to cook. Let's pretend we have a business that makes widgets. I mean, we do all the widgets. Red widgets, blue widgets, 1 widgets, 2 widgets. This isn't a Dr. Seuss rhyme, but it probably should have been. And luckily for us, people love our widgets. But with that comes questions. Is this widget the same as that widget, or how is this widget different? We have to hire people to answer those questions, and we can't hire them fast enough. And even the ones we hire can't keep up with all the changes that are coming as we create new widgets. But we're not just on the forefront of the widget industry, we're also very tech savvy, and we know that, hey, we should build a chatbot on our website that can answer those questions for people before they talk to a real person. But the problem is, we're always coming up with new widgets, and some of them become outdated or have a recall. That's information that we need to consider in our chatbot. But we're in luck because we have tons of data on all those widgets. PDFs, videos, technical specs, web pages, all about these widgets that we can put in one data store, one location to rule all the widget data. But what if we could say to our LLM, hey, before you answer the question, go to our big data store of widget information and pull out the relevant documents for that question and use those as the basis for your answer. Welcome to Retrieval Augmented Generation, my friend. Let's redo our LLM flow to include RAG. So the user still asks their question, but rather than immediately responding, we tell the LLM, hey, use that question to get N number of relevant documents to that question. And then we use those documents and some instructions and prepend that information to the user's original question and say, hey, here's all this relevant data. Use it as the basis for your answer when you generate your response. And now the LLM can generate a relevant and up-to-date answer for that user's question. Pretty cool, right? But how does it work? I'm glad you asked. In a previous video, we talked about vector databases, and I'm not going to go into the details of how they work. We've already got a video up there in the cards that you can watch to learn more about those. But focusing back on our data store, what if we were to take all that documentation, the PDFs, the web pages, the technical specs, and parse through that information to create granular little sections of a paragraph, or a page, or a section, rather than a whole manual or whole web page. And then rather than just storing that little granular piece of information, we convert those things into vectors. Remember, vectors are just an array of numbers that represent the actual data. So when we create those, content about a red widget over here and the red widget return policy over there would be similar because they both talk about the red widget. So those would live in the same area of space in that vector database. Now when a user's question comes in, we convert that question into a vector. And we say, hey, vector database, if I gave you this vector, where would it live in your space? In fact, can you retrieve the 5 or 10 or n number of documents that are most closely related? And that's where the retrieval part of retrieval augmented generation comes from. In fact, the systems that are built to do that are called, appropriately, retrievers. And a lot of work is put into making retrievers that are better and better about returning data that's more and more relevant to the original question. Lastly, we'll send an instruction to the LLM that says, hey, we've got all of this really sweet content that's relevant to a question we're sending you. We want you to use that content to augment your response back to this question. And there's our last word, augment, retrieval augmented generation. Now our LLM can use that content to generate an answer that's relevant and up to date for our user. In fact, when we go create a new widget, we don't have to retrain our model anymore. We just need to add all the relevant documentation and PDFs to our vector database. And then the next time a question comes in for that widget, it's ready to go. You can see where this would solve our problem with out-of-date information in an LLM. But what's even sweeter is that it can tell us what information it used as the source for that answer, which means we could provide links to the user to say, here is our answer, but it's based on this document, and perhaps even like a specific paragraph in that document. Pretty sweet, right? We could even tell the LLM, if you don't find the answer in this content we provide, just admit you don't know. Don't go guessing at stuff. Now, we could dive a lot deeper into any one of those steps, but hopefully this has given you a basic understanding of what RAG is and how you could use it to build better apps. And if there are other AI topics you want us to cover, be sure to leave it in the comments and we'll try to get to it. Until next time.